Hello everyone, welcome to my channel. Today we'll learn an absolutely new language, C language to be specific. We'll be learning functions, variables, and different things to do with C language. Before we begin, let me go ahead and create a new file. Now this is our first C program. So the first thing to do in every C program is to do this. #include. I'll be using VS Code to just make things easier. You could use any editor you want. stdio.h int main void. Now you have to do this for every C code that you're writing. You have to do this for absolutely everything. For your program to work, you need this line of code. It has to be there. And you need this block. Without this, nothing will happen in your code. Now let's begin. Now we should learn about variables. Now a variable is like a container that used to store values. Now for example, if you want to store water, you use a different type of container for that. If you want to store solid objects, there's a type of container that is specifically designed for that. So in programming, also in C language, we have different variables for different types of data. Now for the numbers, let's say 19 is a type of variable that we store. 19 is called an integer. So now int is to store numbers like 20, like 100, like 15, 0, -1 or -2, negative or positive numbers. Now another type of variable we need to learn about. Let me just put that down here. Let's use a readme for that instead. Let me create a new file, readme. Now, so we have types of variables. So we have the integer is used to store numbers. For example, 1, 2, 74, -10, -92, etc. Now we have another type of variable used to store letters, for example, just individual letters like A, like B, like Z, or W, or V, or R, single individual letters. And the variable used to store that is called a character. In C, it's spelled CHAR, short for character. Now that's used to store individual characters or letters. Let me use letters like A, like F, like T, etc. So you can't store more than a single character inside of a char value, a character value. If you want to store more than a character, you want to store a string, you'd have to use a string, which is string. But now in this in C language, it's not really called a string. It's called, we use like a list of characters, so we call it the char star. So now this is used to store multiple characters. So now in other languages like Python, we could have a string that is actually a variable that we could use to store like a sentence that contains multiple letters, things like that. Store string. And then we have the floating point value, float. Now the float is used to store numbers, but numbers that have decimal points, like used to store decimal numbers. For example, 1.3, 1.5, 9.2, 9.7, 100, 190.1, for example. These are numbers that have decimal points. So use the floating point value to store that. Now all these variables have their own purposes because they are storing different types of data. So now in a bit we'll learn how to use the variables individually. Now let's go to some other functions also before we begin to write code. We have functions. Now there are some functions that are built into C language. Now functions like um, functions functions like printf. So printf is used to it's the bash equivalent of the echo command. The echo command used to print strings, print variables, and the printf is used to print out also into the terminal to print values to console or terminal. We also have the putchar. This one is used to provide individual characters. Print individual characters. Now we also have the puts. So this puts works very similarly to the printf. Now there are also some other functions that you could design yourself. The functions that you design yourself are the ones that you make it work the way you want, like a function to add two numbers or other things like that. So now let's move on to write our first C code. Let's say we want to just print out a simple string, a simple letter or a simple word or string, for example. Let's use the printf command. Now the printf hello world, as you can see, we use the printf keyword, and now we use the parentheses, the brackets. Now whatever you want to print inside of this function needs to be contained in this brackets. So whatever you want to print has to be like inside of this. Now you have to use the single or double quotes to surround whatever you want to print inside of this function, which is the printf function. Now in my case, I want to print the hello world. Sorry about that. Hello world. And now this line, this backslash n is used to print a new line. So now this backslash n tells the our compiler or our computer to print a new line. So now without this, it will just print hello world, and then you still have the terminal object in the same line where the hello world is. Let's see how that goes. Now let me go ahead and run this code. Now the first thing you do is you compile the C code, which is gcc first the name of your code first .c -o, and then the output file that you want. If I want to compile my code and I want to compile it into a different output, and I want to specify the name I want. If I don't do this now, you'd see we just get output a.out. That's the default value for compiled files. But now if I want to specify the file I want, I would have to do that by using the .o, the -o command -o. So -output, I want to specify my output file. I can say first, and then you can see we have a file named first that appears here. Now for you to run this code that you've written and compiled, now this process is called compilation. Now there are several ways to do this. You could have in Python, for example, we have the interpreter. In C program, we have the compiler. So what this does is, C is a language that human beings, like programmers like us, can understand. But the computer does not speak in C language. It does not understand it. What the computer understands are binaries, ones and zeros. So what the compiler does for us is it takes this C code, this block of code that we wrote here, changes it into ones and zeros that the computer can understand, so we can move on to for the computer to work with it. So it compiles the code, changes it from the high level language, which is C, to the low level language, which is the binary. So now C is not sort of a high level language, it's a low level language actually, but it's not the machine language that the computer uses. So that's how we work with it. So now to run the compiled file, we use / and the name of the file / first. Now you can see we have hello world being printed out into our terminal, but yet it's in the same line as I said. We don't have it on a new line, which is not what we want. So what we do here is the \n, and now if you want to now run the script again, if you see now if I run / first again, it's still doing the same thing. So what you have to do is recompile your code, which means you have to run this command again, so it will make the changes and store it into this file, So now what we do is run the same command. Now it has compiled. Let me clear my screen, and then we can move on to use dot slash first. And now you can see after printing the hello world, it goes on to a new line. Now let's see some other things, cool things we could do with C language. Now you could also use the put function. Let me remove this put, or let me just add it at the end. Put hello world. So this put is a function that doesn't really require that you provide a new line at the end of it. Let me recompile my code and you see what happens. Let me now run dot slash first. As you can see, I did not provide the backslash n at the end of this put function. Yet it's printed out a new line because that's how it was designed by people that developed this function. They designed it to automatically add a new line to the end of our code. So now this put is similar to printf, but it print out a new line for us. So there are some other differences, but for now, let's keep it at that. Let me clear my screen again and let's move on to something quite different. So now if I want to print out, let me initialize a variable, for example. Now, before we move on, let's learn some practices. When you're writing a C program, you should learn to comment on your code, like document your code, so it's easier for someone else to understand what you're trying to do in your program. So how you do that? How you write comments in C languages? Use this. So you have the / double star and this. So you could also use this, and what this is the most you could also use this. This is a comment. This works fine, but then it's better standard to work with something like this. So now we can say we have the main function, entry points, or whatever you want to make your main function to do, you could just provide it here. Now entry points, and now you can say okay, description, print hello world to the standard output, and then we can say return 0. So now also one of the practices you should learn how to do is after writing your C program successfully and you like get to the end of the code, always return 0. So what this does is lets your computer knows that this code has run successfully. So now if it's otherwise, let's say you want to return an error, for example, you can return 1 to like tell the computer that if something went wrong, you need to let the user know about this. So let's move on to initializing variables. Let me just let's leave this code at this. Let's create a new file so you can always go back to this. Remember, I'll be leaving the GitHub repository where this code will be available inside of the description. So let's create a new file. So let's say variable var.c. Now I want to use this one to like learn how to use variables. So always remember your pound include. So the hash is called pound include stdio.h, and always remember int, main, and void. So as I said, you should always like provide a description to your code using documentation. So now we want our main function, entry point, then the description. No, we don't print the set of data types. We want to print variables. So now let's move on. Also to return 0, that's important. So now let's go on to initialize some variables inside of our code. Now I want to say int number equals 0. And always remember, after you like initialize a variable or run a function in C language, you should always add this colon at the end of it. It's always important. If you don't do that, you would have an error. Let's see. Let's try to do it and see now. Let me remove this and then see. Let me compile my code. Remember the GCC compiler we are using here. GCC, the name of your file, which is var.c, and then the output file -o var. Now you can see we have an error. It did not compile. So now you can see this is one way to debug your C language. If you have an error in your code, you could always look at these values to understand what's really going on. Now you can see var.c, which is the name of our file. In function main, the name of our function, this is our main function. You can see, so that's where the error is coming from in our var.c, then in the main function. So we can always like pinpoint where exactly the error is coming from. So here you can see more information. You can see var.c line 12, as you can see here also line 12 and 1. So it's telling us that it's somewhere around this line 12 that the error is coming from. So now you can see again more details about the error. You can see error expected a comma or a colon before the brackets token. So as you can see, because we didn't put that here, so it expected a comma or a colon before this curly brace. So that you can see expected declaration statement at the end of input. So you can always use this to like understand what is going on in your code. You can like to find out where exactly the error is coming from. So let's move on to compile this now. You can see it compiled successfully, no errors. When I run this script on this code now, it doesn't do anything. You see, because I didn't really do anything. I just initialize the variable. Now let's say its number equals 0. Now if you want to print numbers or variables inside of the printf function, you have to use what is called a placeholder. So now if I want to print a number, for example, the placeholder is percent I is used to like this is a placeholder for integer. Percent I, percent C is for a character, like percent F is for a floating point value. There are several of them like that. So they are used like placeholders for different variables. So now let me use the printf function. Printf the number. So now you can see here I provided my string. But now when I wanted to insert the value of this number, I did %d. That's also for a decimal number, like a number that is from 0, 1 to 10, like simple numbers, normal numbers. Could use %d or %i for that. So now you can see I said %d, then I said my new line, but then you have to provide the number here. So this is the variable I want to insert into my printf command, but then this is the placeholder for that variable. So now let me compile my code and you see what happens. Now /var, you can see this, the number is 0. So now you can see initially I did not really define, I didn't write 0 in this part of my code. But what the program does is it goes into this variable and checks the value of it, then inserts it inside of this place when it's running. So because I said %d, that means I want it to like replace this block of code, this line, with the contents of this variable. So when you're running the program, it goes ahead and checks this variable, then goes back and say, okay, what's inside of this variable? It opens it up and checks, okay, it contains the number 0, and then it replaces this place with the number 0, whatever it's inside. If it's 10, replace it with 10. If it's 9, whatever it is. So that's what it does. So now let's go on and change this and see if it actually works like that. Let me say 18, for example, in this place. Let me recompile my code and then run /var. You can see 18 also. So it automatically checks and replaces it in the line of code. So now let's say for example, now I said the %i could be used instead. That will still work fine. Let me recompile my code and run it again. You can see it still works because it's an integer and it's also a decimal variable, like simple numbers from 1 to 10 to 11 to 18. But then the floating point value contains a point. So that's what that's all about. So let's move on to change. Let me change this back to d and yeah. Now let's learn some other things also. So let's say we want to print two different variables to the terminal. Let's say int number 2 equals 20. You remember when I said you have to like define the types of the values. So now this int tells our computer that okay, this variable is going to contain an integer. I don't know what it is yet, but it's contain an whatever it is, it contain an integer. But then if I provide a value here, let's say I provide something else like this, will cause an error because I told the computer that this would be an integer, but then I'm providing in something else, so that will cause an error. Let's try to compile and see what happens. Let me say in compile. So now you can see as again you can learn how to debug using this output /c in the function main. So our error is coming from this block of code. Now you can see C 18 11 18. So that's telling us like in line 11 and column 18 we have our error there. So line 11, and you can see it falls around somewhere around there. So now you can see warning, initialization of int from char* makes a pointer without the car. So it's telling us now that you said you want to store an integer, but now you are providing char*, which is a string. So that is the error. So let's go ahead and change that back to a number and move on with our code. Okay, let's say 10. So now if I want to print two different values inside of my printf function, how do you think that will happen? I have to provide the second number here also. So what this does is to print out two different values. Let me put the comma button here. The second number is %d. But then what I have to do here is I also have to provide the second value, which is number 2 here. Number 2. So now how the C compiler understands this is it checks for these placeholders. Checks, okay, this is the first placeholder in this code. Then it goes ahead and checks this other side and checks for the first value. So this is the first placeholder. It checks for the first value also. So it matches the 1 to 1 and 2 to 2. So it's accordingly in respect of the order that they appear inside of your line of code. So if I put this number 2 in this first place now, it will appear first because that's how it's like designed to work. Now let's go ahead and compile our code again, then run it this time. So you can see the first number is 10, the second number is 20. So that works fine. Now let's learn how to print strings or characters. Let's say char, char, letter equals a. Now this is, let's say, print the letter so this is the letter %c. So it's like the same concept as the previous line of code that we are using. We are using the placeholder %c for a character, and then the variable that I want to like print out, which is the letter variable. So when I compile my code now and I run it, you can see the letter is a. So that works fine. Now let's learn how to do arithmetic operations inside of our C code. Let me go ahead and create a new file for that. Let's say operations.c. Now always remember we want to have I forgot to return here. Always remember to return 0. So that's the right way to do things. Now let's go ahead. Let me close my editor, and always remember you have the pound include stdio.h int main void, and then your curly braces. So this is always important. But then also don't remember to like have your documentation. So entry points. So now we want our main function as the entry part of the code. Description. You could always use whatever you want for it. I can use DASC and continue like this. This is defined. But now we want to like learn about arithmetic operations. So let's learn about adding two numbers. So let's use the sum of two numbers and then return 0 always. Now let's initialize two variables. Remember we have to do that using the int number 1, int number 2. So now we've initialized two variables. Now how do we add these two variables and then print them into the terminal? So now let's initialize a different variable now. Int sum equals number 1 plus number 2. So like it's as easy as this. I created a new variable. Then I want to store the values of the addition of these two numbers. So now number 1 and number 2. So those are the ones. So now number 1 plus number 2. So what C language does is, now this equals to, now it could confuse you a little bit if you need to program in. It's not an expression like it's whatever is in the left is equals to whatever is in the right, like mathematics. It's quite different. So this is an operator to like copy the contents of the right to the left. So what this does is it evaluates this expression on the right, evaluates it and stores the outcome inside of this variable. So it evaluates the right and stores it in the left. So it go ahead and check number 1 plus number 2 and then add it, then go ahead and store the outcome inside of this variable. So now if we should print this now, and then we should be having the sum of these two values in this place. So now let me explain this line of code. The sum of %d, remember this is a placeholder. We want the first number to appear here. So that's number one. So you can see it matches number one and the first number. Then the second placeholder should match the second number. Then the third placeholder should match the third number, which is the addition of the two numbers. So we initialized two variables once again. We added the two variables and stored them in a different variable, sum. Then we went ahead and printed out those values. So now let's compile our code and see what happens. So now GCC, always remember the name of your file, which is operations.c, and then -o, the output value, operation. Okay, we don't have okay, my file is not in the proper directory. Forgive me for that. So now we have my file. Let's run. So now we've compiled successfully without any errors. Now let's run our script and see what happens. /operations. So now you can see the sum of 10 and 20 is 30. So it automatically let's go through the code again. We initialized two variables, the number 10 and the number 20. Then we added those two variables. So now if you evaluate this code, you find out it's 10 plus 10, 10 plus 20 equals 30. Then it stores the value inside of this variable, sum. And then we printed it out here. So now if we change these values now, it would still work fine. Now let me recompile my code. Always remember to do that. Recompile and then run. So now you can see 10 plus 1782 equals 1792. So that still works fine. So now let's go on to learn some new, or let's try the subtraction instead. Let's say int difference equals number 1 minus number 2. So what this does is, like, it's the same as before, just the different arithmetic operator, which is the minus instead of the plus. So it evaluates this value and stores it in this value. So now let's reverse these values. Let's say 2000. Now when I recompile this code, let me first print out my values here. So now printf. So that I printed for the sum, I printed for the difference also. So now let's return 0. Don't forget that. Return 0, and always have that in your parentheses. So now let's go ahead and recompile our code. Dot operation. So we can see this sum of 200 and 170. So that works fine. So, and the difference also, as you can see, I said you could store negative values inside of integers. So as you can see here now, we have a negative value that was stored in an integer. That works fine. So it's still an integer because it's still a number, just negative number. So we have the minus 1582, and that works fine. So that's all about arithmetic operators. So let me say goodbye for now. We'll learn more in the next video. So please like and subscribe.